Welcome. I've been talking to a number of people over the last couple of days about the talk that I'm doing, and they keep asking me, so what's the talk? And I give them the name of the talk, and it's long, and my tongue gets tied over it. So I decided I needed to shorten the name of the talk. So this is a famous acronym that's related to this subject. Curious, who's familiar with this particular acronym? Yeah, not too many. That's not surprising. Who would say they're really comfortable with the whole idea behind this acronym? Yeah, even less hands. That's because the acronym stands for Hypermedia as the Engine of Application State, which is some wonderfully academic thing that doesn't mean anything to anybody. So I decided for my talk I would rename it as Hypermedia as the Evader of App Stores. See, that is actionable. We can understand that. We can get that. So who am I? My name is Darrel Miller. I'm a developer advocate for Runscope. Runscope build developer tools for people who are using web APIs. If you want to measure or monitor a web API, then we have tools that can help you. I'm also a Microsoft MVP, been that for a number of years, and I've been heavily involved with the Web API Advisory Board at Microsoft, and I got involved in co-writing an O'Reilly book, Evolvable Web APIs, with some of the team members of Web API and some of the other advisory board members. So, what do I know about Hypermedia, right? I know I've been building line of business desktop applications, fat client desktop applications for 20 years. For small manufacturing businesses, I've done inventory management and accounting and purchasing and the whole range of line of business stuff. And the one thing that is always true is deploying native applications is a pain. And it's the same in the mobile space, but you've got slightly different problems. You've got app stores, right? So some of the things are easier, some of the things are more painful, but it's generally a common problem. And I also know from my experience the last 8 years working with line of business applications and trying to use Hypermedia on the client side to try and reduce the amount of times that I actually have to deploy client applications, that it can work. You can start to use Hypermedia to help you avoid some of this deployment pain. Because Hypermedia allows distributed systems, the components of distributed systems, to evolve independently. So you can change the server without changing the client and vice versa. So it all comes down to where to put the business logic. And we as an industry have been playing this tug of war for 40 years as to where business logic goes in our applications. We had the mainframes where all the business logic was over on the server side, and we just had dumb terminals. And then we had the PC revolution, where the PC, we put everything on the PC, and all we had on the server side was file servers, just dumb bytes. And then web happened, and we moved all the logic back onto the web servers. And then now we're changing again. We're doing JavaScript, right? And we're building rich JavaScript applications that run on the client. And each time we move where we're putting. And one of the problems that I'm seeing in some of the JavaScript stuff that I'm seeing at the moment is developers are starting to make the same mistakes that some of us old guys made in the 90s when we were building client-server applications. And one thing that I've found is that HTTP and Hypermedia allows a really nice balance of roles and responsibilities between the client and the server. It allows the client to richly display the information that's returned back from the server, and it allows the client to capture intent from the user and transfer that up to the server in order to perform business logic on the server. But in order to do it, in order to take advantage of Hypermedia, you need to build a different style of client application. Before I go too far, I just want to clarify on the term of hypermedia and what exactly I'm talking about. Really, all I'm saying when I'm saying hypermedia, I mean when you get a response back from the server, there are links in that response that point to other resources that exist on some other server. I mean, we deal with it day in and day out in the web browser. We're used to clicking and navigating around to find information and interacting with applications on the web. But we're less used to this idea that we can take those same concepts and use them within our native mobile applications, or native desktop applications for that matter. The problem is, there's lots of people who like to talk about hypermedia, and there's lots of conversation about it, but there's not a whole lot of code out there and examples to see. On the server side, it's getting better. We're starting to see more hypermedia APIs. GitHub have a hypermedia API. Microsoft have their document DB that they recently put out has hypermedia in it. Their Link API does. And even Sabre, the old dinosaur of airline companies, they put out a new developer API, and they have hypermedia in their responses. So, but that's on the server side. Client side, we really don't see a lot of examples. So that's what I want to try and do today. So I want to start with an extremely sophisticated API, an on-off switch. And although I jest it is simple, but it has two factors that are redeeming. One, it is not a read-only API. It is actually a read-write API. And two, it's not CRUD. And I can be quite sure that within a larger API that you build, somewhere along the line, you're going to want to have some kind of toggle type of interface. So it brings up some interesting conversation pieces. So I'm going to switch to code. Okay. Forgive my control of this Zoom window, but here's my solution. I have a couple of different native clients. I have a Windows Phone and a WPF and an Android that I experimented with, but kind of got stuck when I got to the UI because I don't have a lot of experience in that UI area. But the key thing is we've got this Switch Client portable library. It's completely reusable code, no dependencies on any user interface framework. And that library is completely shareable throughout the different client applications. So I'm going to start off by looking at this classic folder here. So here, this is how I see most people when they try and work with web APIs from client devices. This is how they kind of do it. They'll create a service class. A switch service class is kind of a wrapper around the API, and it encapsulates all those interactions that occur with the web API. And then we pass that service into the view model. So let's take a quick look at this just so we're all on the same page. So within this switch service, I have some hard-coded URIs, the relative links. I have the switch resource, the on resource to turn the switch on, and the off resource to turn the switch off. And I have a couple of methods, one which goes and gets the current state of the switch, and the other which sets the state of the switch and calls a post to the appropriate resource. Pretty much standard stuff. And then we pass it into a view model, and the view model then makes a request to the service to go and get the state of the switch. It stores that state of the switch, and then it re-exposes the state of that switch in a bindable way so that we can use data binding or whatever to allow the user interface to access that data. And then we have a couple of methods here. We have a turn on and a turn off that do what it is obvious that they do. I use data binding here, so I have also a property which is can turn on and can turn off. And I have a little bit of logic that just says, well, if the switch is on, then don't let you turn it on again. And if the switch is off, don't let you turn it off again, right? So this is that simple, and I'm going to run this. And you're going to see my wonderful application on, off, right? That's it. So let's now look at how we would do this in a more hypermedia-driven way. So now, instead of having the service and the view model, I now have this class called a switch document and a hyperview model. Now, the point here is now I'm focusing more on the message that's returned. I'm going to use this switch document class in order to interpret the message that comes back, and then use that document and feed that document into the view model. So wrong one. Let's look at the document. Okay, so it's dead simple. I have an on method, and I have these an on property. I have these two other properties, which is the turn on link and the turn off link. These may or may not be null in this document, depending on the response that comes back from the server. And I have the static method that will just load the stream. It's just a bunch of JSON that comes back, and I populate this document object. But the document contains the semantics, the data of the switch, and also affordances in order to allow me to interact with that switch. I then pass my view model. Now we'll make a request over to the server. Now the only slight difference here is I added an accept header to tell it, don't give me the standard response, give me this response that actually contains the links in it. But that's just because I'm using the same server to drive both of these clients. And I get the result back, and I pass it to this update state method. So what I'm doing here is I'm getting the document, and I'm taking that document, and I'm applying it to the view model and saying, update the state of your view model based on this new representation that I have just received. And I look at the response and check the status code and load up the switch document. And then at that point, the view model really just becomes a wrapper around that document to re-expose the on property so that I can bind to it, and I have my turn on and turn off methods. Now the turn on and turn off methods now make a request directly using HTTP. There's no encapsulation of the service layer anymore. I'm just literally making an HTTP request to that link that I received, and then I get the response back, and I re-update the state. So it's not tremendously different. The only difference here is when we get to the can turn on and can turn off, that logic just says, well, did I get a link or didn't I get a link? Because it's the server that's now deciding whether or not that link is going to be displayed. So if I head back up to my app.xaml, I can just change it so that I just use a slightly different, use the other view model. And I start that, and I get exactly the same behavior, right? The difference now is if I go over to the server and I look at the switch controller, which is the controller that's returning the responses on my server side, is if I have this logic that does the can turn on and can turn off over on the server side, and I can now change this logic here. Now, obviously, just having a simple Boolean is not really representative of what you might actually do, but you can envision an environment where, well, you can't turn the alarm system on while we're during office hours, or you can't open the safe. There's many different logical reasons why you may want to enable or disable why somebody can perform a particular action. And the fact that I can now do it on the server, if I could actually stop this from running, I rerun the server and rerun the application. Unchanged, I now cannot turn it on or off, right? It's dead simple. So what am I doing here? I'm using the links to convey the options that are available to the client. And I'm allowing the links to capture the intent. It's about saying the client only cares about what the user wants to do, not about how they're going to do it. But really, this is a very simple example with one view model where we're only looking at one part of the puzzle. How do we build an entire application that allows me to navigate around the application using Hypermedia? So for that, we need a slightly more complex example. So this is how I like to draw my Hypermedia APIs, with just little boxes and arrows between boxes. So the first, the orange box there is the expense home. With Hypermedia APIs, it's always a good idea to have a home starting point document, because the entry point URI to an API has got to be fixed and hard-coded. But what's going to happen with the client is as soon as it hits this first box, it has some rules that says, well, go and tell me where I should now go to get the first piece of information that I want to display in the application. And in this case, we're just going to go to a list of expenses. Now, that could change in the future, and I can change it on the server side. I can also add other links into this initial home document. I can point to the authorization server. I could point to resources that have preferences for the user. There's a bunch of different purposes. I could point to documentation. So it isn't actually visualized on the UI, but it's used as a starting point. And then from the expenses, I'm going to get a list of expenses, and I'm going to be able to do things like approve and unapprove, and then see receipts associated to those individual expenses. So once again, let's go back to code. So this structure is kind of familiar. This time it's like a Windows 8.1 app and a Windows Phone app. But again, I have the core piece, which is that portable class library that's shareable. And in that portable class library, there are three fairly important architectural concepts for this style of building applications. The first is this class called expense app client state. So this client state object, you can kind of think of it as a view model for your view models. It is an all-encompassing thing that holds the state of where your current application is at this point in time, which gets very handy when it comes to trying to do the suspend and resume type of stuff. The next thing is we have view models, same as what we're used to dealing with. Nothing majorly different there, other than they're bound to Hypermedia type of documents. And the other concept is this notion of a link class. Now, I just want to clarify the distinction I make between a URL and a link. A URL is just an identifier. It points to some resource on the server. A link is an identifier with a bunch of attributes that tells you more information about how to interact with that resource on the server. And one of the most important attributes that exists in a link is the relation type, or the rel as we often know it. You're used to seeing in an HTML document, link rel equals style sheet. Well, that word style sheet is like a type. It's a type on the web, and it tells the web browser this is how the web browser should deal with the response that it gets back when it follows that link, when it uses that identifier, the href, and dereferences it. Whoop. Okay. So these link classes that I've created, action, home, link, show, they're fairly generic, and that's one thing that you want to try and do. There are standardized link relations out there that are defined by the IANA registry, but you're allowed to create your own custom extension types. And you document those as part of your Hypermedia. When they come back, you have an identifier that tells you this is a show link, this is a home link, this is an action link. And that allows us, when we're deserializing the representation, to know which kind of link we're dealing with. And these particular link classes I've derived from a base class, a base link class, that I have as part of an open source library that's on GitHub. And I've built a fair amount of tooling to help people work with Hypermedia APIs on the client side, because there are some mechanics there that are a bit of a pain. But the concept is way more important than that library. You could easily re-implement a lot of the things that I've done in the link library. Okay, so let's see how this application actually starts up. We're going to go into this, the 8.1, and go into this app.xaml. And you'll see the first thing that happens in the initialization of the application is we new up an HTTP client, because we're going to go direct against this HTTP client. And we new up one of these expense app client state objects. And I pass in the HTTP client because it's going to make requests for us also. And then I hook a property handler up, because that's what's going to happen. The client state is going to change, and the UI is going to listen to events on that client state object and react to those changes. So the standard launching point of this type of application is this onLaunched event handler, and this is the line of code that really gets everything going. I have this follow link async method. And follow link's just a little helper method that I've hung off client state. We'll look at that in a second. And I'm saying I want to follow the link to this home link. Well, home link's a little bit special. As I said, an API tends to have one hard-coded entry point. So encapsulated inside that home link, it knows where to go and find my API. It also has some other logic that says, well, when you get the home document back, go and find the first show link in there and go and follow that link also. So there's a bunch of logic hidden inside that home link. But conceptually, that's where we're going to start. So now let's look at this follow link async method. So this follow link async method does three things that are fairly interesting. One of them, it deals with this link generically. It passes in just this base link type, and it calls a method called build request message. Because what we're doing is we're using this typed link class as a factory for building our HTTP request message. It knows whether it's a get or a post. It knows whether or not there are certain headers that need to be set, whether there's a payload that needs to be set. It's all hidden inside that link class. So we get a generic HTTP request message back from that build request message, and then we send it along to our standard HTTP client send async method. We get the response back from that, and we call this apply response. So we're applying the entire response that we got back from this HTTP request onto our client state object. We're saying take this representation and make whatever changes that you need to this client state. The client state is going to do whatever it needs to do, change whatever properties it needs, and then it's going to raise events, which the native UI is going to capture and change the user interface to reflect the client state. Now, React is a key word here, is we really want to try and break the request-response coupling in order to get that ability for the client and server to change independently. If we look back at our follow link async method where we called here before, you'll notice I follow it, I follow that link, but then I don't do anything with the response right after it, right? It's kind of a fire and forget, because what I'm doing is I'm sending the request out, and then the application just sits there waiting for a response to come back in and deals with that response however it feels it is appropriate. The advantage there is if over time the server changes its response to a particular input, then there's a good chance that the client may still be able to handle that response. It doesn't need, you don't need to couple whenever we make request A, we get response B back. It could be one of the other responses that we get back that the client knows how to support. And we'll see a couple of examples of that. So let's look a little bit more into this apply response async method. So what we do here is we get the response, well, we get a response task back. I await that. We get the response. And then the first thing I do, and I sort of lied to you a little bit, I do get some context back. I go in and I find out, well, what type of link did you follow to get this response? Was it a show link? Was it an action link? Was it a home link? So the combination of knowing what type of link I used to get the response and all the self-descriptive information in the response, with those two pieces of information, I'm then able to do a whole bunch of things on my client. The next step is we take advantage of the uniform interface of HTTP. I look for server errors, I look for client errors, I look for redirects and stuff. One of my pet peeves is when I see API documentation and they have a resource there and it says, this resource will return this status code and this, the 401 and a 404 and a 406. And I like to ask, well, wow, how did they implement an API that never returns a 500 or a 503? It's like, you can't turn around and say, I only return these response codes. You might not today return a redirect, but sometime in the future you might want to. So don't make a contract with your client developers to say, these are only the HTTP status codes. No, you need to build clients that can react to any of them. And it's fairly easy to do if you funnel your responses through some fairly generic handling code and look at HTTP status codes as ranges. Like, okay, if it's a 400 range, we're going to do this. If it's a 500 range, and you can pull out specific ones and put specific handling to specific cases. You don't need to write specific handling for every single one of the HTTP status codes, right? But you should at least plan for the fact that they may happen. The next little bit of code here in processing this response is I look at some link headers. The thing about Hypermedia is it works great if you're using textual representations where you can embed links, but what about when I'm returning images, right, or byte streams or stuff? So you can actually put links up in HTTP headers. So we'll see an example of that when I actually run the application. And then the last part of this applying the response is I kind of do a dispatching, right? I look at the link that I use, the context link that I used, I followed. I look at its relation, its link relation type, and I do a little switch on it, and I say, well, if it's a show link, then, okay, we're going to do this. But I don't actually put the code in here. I hand it back off to the strongly typed link, because that link encapsulates not only the creation of the request, but also the handling of the response. So we hand our response off to the show link, and it does whatever it needs to do to process the response. And we've looked at enough code. Let's actually show this application running. Let's take that. Let's do that. And let's run this. And you will see here now why I am a very strong supporter of using UI designers when designing your applications. Okay. So we just get this little list of expenses that appear on the left-hand side. And actually, this is not the screen I wanted to show. I wanted to show this one. So my server's running as a little console app, and I'm just outputting the requests and responses here. And you can see how the application initially hit that home expense app resource. And I return back home plus JSON, which is a standard media type for doing discovery of existing resources. And at the moment, I only have one resource in here. It's the show resource. This kind of URN Tavis show syntax, it's just, the rules are, if it's a standard link relation, you're allowed to just put a simple string of text. If it is an extension, you're supposed to put a URI. And I don't like putting the HTTP : whack, 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 blah, 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 blah. So I tend to use URNs, which I'm probably not allowed to do either, but nobody's knocked on my door yet for it. So then the client automatically says, OK, I'm supposed to follow the show link, so I'm going to go to get expenses. And what comes back is application/vnd.collection plus JSON. So this is another media type that has been designed specifically to return lists with links in it. And you can see here I have the data that's appearing over here. And also, I have a set of links at the bottom. So I have this first link here, which is a show link that shows me the details of the expense. Now, I didn't actually put a button up on the screen for that, because you don't have to, right? Just because there are links in the representation doesn't mean you're committed to expose those. You have the option to expose it. Now, you can also build more of a dynamic user interface that would say, OK, well, whatever links are here, I'm automatically going to create a button to expose those. That's another way. It's up to you how much decoupling that you want to do between client and server. And then I have a show to be able to go and show the receipt. And I have an action link in order to reject a receipt or approve a receipt. There's a couple of interesting things about this representation that aren't visible because they aren't really there. When I define this set of expenses on the server side, each of these expenses has an ID. It happens to be an integer. And in fact, you can see it embedded into this URI here, right? The thing is, maybe somewhere further down the road, we decide, we really want to be able to create these things independently without having to go back to the server to be able to find out what the next ID is. How about we use GUIDs instead for identifying these? The thing is, I can now change that on the server to be a GUID, and the client doesn't care, because the client just sees it as an opaque link. It just follows it as it's just a link. It doesn't care what the bytes are that are in that string. Another thing is like, the buttons, the approve, the unapprove, if I click those, they're going to enable and disable based on the state machine that I've defined for these expense items. And those state machines are things that businesses love changing the rules. Oh, well, if it's over this amount, it's got to go into this other state. And if it's to this particular place, we're going to put it on hold. And the last thing that you want is, oh, well, we can't implement that new workflow that you want because we have this enum on the client side that enumerates the different states, and we'd have to go and add another value to that enum. I don't even return the state here. I don't need to return the state of it because I'm returning what the user can do because it is in the particular state. There is a state machine on the server side to tell me which links to display, but it is not. I don't need to expose it over the wire. And as you explore this technique, you'll find there's more and more of these kind of things where it's like, Well, I don't really need to tell the client that information in order for it to be able to do what it's supposed to do. So why bother giving it to it? Because that would allow me to change it without impacting the client. So let's click on one of these receipt buttons. So I click on the receipt, and I get this pretty picture of a receipt that I took a photograph of. And you can see over in the header here that I have embedded a link. And it's a backlink. So that when I click this back, it's going to take me back to expenses. Now, I haven't worked in lots of different mobile UI platforms, but from what I have seen, they tend to provide certain infrastructure to help you do this, right? To provide you with the history and to be able to navigate from one screen to another. And they provide some support infrastructure to do that. The problem is that support infrastructure is now in your UI library, and you got to write it multiple times, once for each platform. In this mechanism, it's just another link, same as all of the other links, and you can have this in your shared code, and the server can redefine it without redeploying. Now, this receipt over here, this rental car, it isn't an image. It's a PDF. So it didn't open in the same way as the other one. This time, because I don't know how to embed a PDF into a WinRT type screen, so I said, well, okay, I'll just take the bytes, write it out to a file, and then just kind of do a shell execute launch on the file and let the OS render it. So that's what I did. So both the receipt buttons that I pressed, they both follow a show link. But the show link itself doesn't just use its own context to know what to do. It uses its context in combination with the media type and all the other headers that are in the response to decide how to behave. And I'll show you that little bit of code. So we saw here in the bottom of our client state when we're applying the state onto applying the response onto the client state, that the last step was this kind of dispatch. And we dispatched over to this show method. Let's process the show link response. So in here, once I grab the response body, I then look at media type and say, well, okay, if it's a collection, then I'm going to change the current collection on the client state object. If it's an image, I'm going to change the current image. If it's a PDF, I'm going to change the current file. So these properties on client state have the whole iNotify property change thing. So they raise events, which then gets captured by our user interface. And our user interface says, oh, okay, well, if the property that's changed is current collection, then, well, let's go and display a list page. Let's navigate to the list page. If it's an image, let's navigate to the image page. And if it's a file, well, just call the show file method that does that, writing the bytes to the wire and doing the shell execute. Now, this is a fairly simplistic client state model. Real applications will probably have a more complex client state model. I've built on desktop really complicated ones that have big trees of, because you have lots of open windows and modal dialogues, and so you build up a fairly large object graph of the current client state. But it's a very useful object to have around because you can work with it. And although this is a simple example, I think it's a good starting point, and hopefully you've seen that this is one way that you can take a slightly different approach towards building client applications that take advantage of Hypermedia. So this idea of having an implementation artifact that represents the client state, I think can be very valuable, especially when you get into this suspend and resume notion. And it's useful insofar as having a centralized place to process HTTP responses in a generalized way before dispatching it for its specialized handling. And I found the notion of link types to be very useful to encapsulate behavior and focus, okay, these link types are the parts where we're coupling between the client and the server. If I change the meaning of a link, then I might very well break the client. But they are very reusable. We saw how we used a show method to show a collection, a show method to show an image. The client has very similar behavior, no matter what it is that we're showing. And allowing the server to take over this role of the entire application workflow can help us, A, reduce dependencies on UI frameworks, but it also allows us to incorporate even more significant change into the workflow of your overall application. And I believe that putting your business logic on the server can save you trips to the App Store. And with that, I'd like to open the floor up to questions. Yes, Huck, do you?
I've got two questions. The first one is on performance.
Yes.
If you're having, let's just say you're in an environment where you have different levels of latency and you're waiting for the commands from the server to know what to draw before you draw them, a lot of times you provide a smoke and screen by displaying all the controls first and it gives and then displaying the data later. You sort of lose that. How do you work with?
Well, you don't necessarily have to draw the controls after. You can render a user interface and get the data later and simply bind. So a large part of the UI construction can be done up front, and then secondarily, you do data binding, which will maybe just enable and disable fill-in text box.
Provided you know what the next screen is before you go to retrieve that.
Provided you know the next screen. Yes, you're right, but you can split an HTTP request into two parts. You can get the headers back and use the headers to help you dispatch, because you know what link you followed. You can see the media type in the headers. You don't need to start downloading the bytes before you can start displaying the user interface. So you are absolutely correct in the fact that, look, I'm advocating a mechanism where you are fairly dependent on making HTTP requests. What is advantageous is the fact that generally the HTTP requests end up being limited to one per human interaction. What I have found in the past with applications that evolve over time is the first versions are really efficient, and then new features get added, and then what ends up happening is when a user presses on a button, we end up making 3, 4, 5 requests, because after time we've added, well, we need to add some additional permissions on this. We need to check to see if this condition is true to enable to do this. So you start to lose visibility in the interactions that happen between the client and the server as the application progresses over time, and you end up making more round trips than
so the net effect could actually be quicker because of the.
It could.
Okay. And the second question is, how do you deal with more complex UI screens? So I see that you have a basic renderer that you got these text box or these buttons, and that's fairly simple. If you need to introduce a new screen and you want to be able to not have to put out a new build for the app flow, how do you handle? Because there's dynamic compilation with the code is not available on most the mobile platforms. How do you handle that?
You can't add completely new screens, right? You can start to look at screens in a more generic way. Take the collection plus JSON list concept type. It is a media type that defines a list of things. It doesn't say that it's a list of what, right? So if you build UI that can inspect that and say, okay, here's a list of things, let's display the list of things, you may not be able to create a completely new screen, but if you need to add a new list of something different, you might very well be able to use that existing screen that displays a list of things. Because if the only interaction model with that list of things is, well, once we've displayed the list, we want to select these 4 things and then press this button, then I can do that completely generically, right? So you cannot easily introduce completely new screens. Having said that, I have had some success downloading XAML as a format and using a XAML reader and generating UIs on the fly on the client side. I don't know whether that works on Windows Phone, and I'm pretty sure it's against the terms, the end user license, the Windows Store rules. But it is feasible to do that if you really wanted to. Thank you. Yes?
So sort of if I were to recap the session, basically what you're saying is that you can build a very thin but sophisticated generic client that is driven from the server. The advantage is that you don't have to update the client as often, but the disadvantage is that you probably lose some richness of the user interface and you're dependent on the server because you cannot work offline. So how is this better than a web application?
Oh, how is it better than a web application?
Because really, the web application is, taken to an extreme, your approach taken to an extreme is a web browser client and a server.
Let me kind of flippantly throw that back at you. Why is Xamarin better than PhoneGap? Right? We're here because we think that native applications have an advantage, right? And I am a big believer in the web architecture. I think the web browser itself is one of the most successful distributed applications out there. I just don't quite understand why it is that more people don't adopt the architecture of the browser, because this is very much what I'm doing. I'm building native client apps that behave in very similar ways to the way the web browser works. The only difference is I chose not to use HTML as my media type. All right? So web browser is a fabulous thing. The problem with web browser is not the web browser. The problem with web browser is HTML, because HTML is limited in the semantics that it can deliver and is limited in its interactivity model, and which is why we need big JavaScript libraries to accommodate for the things that HTML cannot do. So on the one hand, yeah, I'm basically re-advocating for the web browser model, but just not using the web browser as a client.
Okay, thank you.
He's laughing because I'm going to ask him the question that I sort of posed to him before the talk. So
it's only because he wants to have a T-shirt, right? Because I'll give anybody who asks me questions, I have lots of T-shirts here, and these are fabulous. Everything is going to be 200 OK T-shirts.
It's a lot like the shirt I'm already wearing, but I want another one. So there's sort of, actually, the recap was really good, right? This recap of the talk was, it's really good to have this idea of kind of client state and be able to communicate that from the server and have the client be very reactive to that and accepting of whatever state sort of came down. And I'm totally sold on that. But as you know, because we've discussed it before, I'm not totally sold on hypermedia as the idea of URLs being passed around. And I guess I'm wondering, what would you lose if you took the URLs out of there and instead put, say, IDs or Booleans for, you know, you had sort of, can I turn it on? Well, that depends on whether I got a link for turning it on. What if we just had a Boolean that said, can turn on, true or false, right? I guess the question to sort of bolster the hypermedia side of this is like, what are the advantages of actually putting URLs in those messages versus some other kind of data?
The integration is the main answer to that. We live currently in a world where we look at web APIs as these bounded things where I write a client and I communicate with that particular API. But as we discovered on the web, after the web started to really take off, people came up with these notions of mashups, and they started pulling information from all over the place, and it was those composite things that really made the web flourish. And we can do that exact same thing on native applications once we start to get more standardized media types that we can communicate across, so that now my mobile app that's looking at, I don't know, the weather can go and retrieve information from a completely different service. And it's just a matter of, you want a standardized way of addressing things. And URIs happen to work. Yeah, they're ugly. Yeah, they're kind of long. But it's a matter of, let's just pick one and stick with it, right? And the other advantage of URIs is they are dereferenceable by standardized libraries. Whereas if you just have an identifier, you need custom-specific code to know how to dereference that particular identifier. Any other questions? Yes.
He touched on it, but I just want to make sure, very clear, black and white. The really only type of application you can apply this to is an application you're expecting constant connectivity, right? I mean, have you come up with some clever way to deal with offline viewing or editing and syncing later?
There are ways to deal with offline. I haven't found a fabulous way, but if you look at the architecture of HTTP, it is a very layered architecture in that, in theory, you could have a local HTTP server where while you're offline, the client, instead of hitting that remote server, hits a local HTTP server and gets some, what's the word I'm looking for, not deprecate, but a scaled down version of the application because you're getting responses from some local intermediary. And I've played around with that insofar as creating intermediaries that you route through, and whilst there's connectivity to the back end, the request will go through. But if there is no connectivity to the back end, that intermediary will step in and it will return a secondary response. So the client becomes ignorant of the fact that it is all of a sudden disconnected. It's just getting a different response back. But again, we built a reactive client so that it just does something different with the response that comes back from the server. So no, there's not an amazing solution to it. The key thing is that this works really well when concurrency is important to you because the data's on the server and it has the most recent version of the data. If you're working in your own private piece of data and it's your stuff, just bring it down and sync it. Don't get it from a web API. It's not the best way. But if concurrency is important to you, then this approach can definitely be valuable. Thanks. Any more questions?
Only because nobody else was going to say something. It's actually more of a response to sort of the question. So syncing is what I do. I work at Dropbox. I do have a talk tomorrow that I'm now plugging, apparently, that's about syncing data and how to deal with offline and caching. And the approach that tends to show up there is actually very similar to this. I think these aren't as divergent as they appear. The idea of having that client state and then rendering UI based on that client state and then communicating changes to the server and then getting a new client state, that's pretty much data syncing looked at through a slightly different lens.
Yeah.
And so I don't think you have to actually change your application architecture in a huge way to support that kind of offline view, although you do have to build a more coupled, it means you have to put a lot more of the UI logic on the client because you can't rely on getting that information from the server. So the benefit Darrel's been talking about avoiding these round trips to the app store, I don't think you really get if you go in this sort of offline model. But the idea of driving everything from sort of a state object that encapsulates kind of what you're looking at and what the data is at present, and then updating that later by talking to a server, that's exactly the same. So that model you don't have to give up, I think. So I just wanted to throw that out there. They're not, they look fairly different. The approaches look different, but they're not, in terms of how you drive the UI and how you manage state, they're actually very, very similar.
Okay. And with that, I thank you all very much. If you have to ask a question, come get a t-shirt. If you've tried out Runscope, come get a t-shirt. If you really, really can convince me that you're going to try out Runscope, come get a t-shirt. Thank you very much.